Before we move on, I just wanted to highlight why the gradient is different to the derivative. So the derivative is our dy over dx. Oops. Here. But our gradient is this. Change of y over change in x. And that's because the gradient is just at one point. So the gradient could be here. The gradient could be here. But if the gradient is just at one point of the graph, it's just a value, it's just a number. Dy over dx is the function. So it's this function. We can draw a graph of it and it gives all the gradients at every point. So yeah, that's the difference. Okay, so let's talk about stationary points. So stationary points, with me, stationary points are basically also known as turning points. So if we think about a graph, the turning point is this point here. Well, it's not always at 0. You draw it like that. This kind of looks like the graph we had earlier, but this is the turning point. It's when the gradient stops being negative and starts being positive, or stops being positive and starts being negative. It's basically the minimum, but we can also have the maximum as a turning point, like so. And it's basically when it changes. There are 2 points, right? Either it'll be going downwards, and then after the turning point it'll be going upwards, or before the turning point it'll be going upwards, and after the turning point it'll be going downwards. Obviously that depends on whether it's a maximum or a minimum. Right. So what you can say is that we have, when we have this first case here, this is known as the minimum of the curve. This is known as the maximum. Right? So these are 2 different types of minimum point and maximum point. These are 2 types of turning points. Okay? Now if we go back to our previous example here, we can see that we have a turning point here and a turning point here. And this one's a maximum. And this one's a minimum. Right. Okay. So, but how does calculus help us find this turning point? Well, there's this rule, and it's that at the turning point, or at stationary point, dy over dx equals 0. And that is why it's important. And it kind of makes sense if you think about it. At this turning point, the gradient is equal to 0. Because it's not going up or down at that one point. If we go back here, it's just staying the same. And we can actually see here that this is the graph of the gradient function. The 2 points that it's 0 are at 0 and 4. Oh, I think it's 4 over 3. So that denotes, that works. 4 over 3 is our other stationary point. So let's do a question like this. Okay, let's do an example using this fact here. So example, in fact I'll do that to separate it. So the example is to find the coordinates of the turning point on the curve y equals 2x squared plus ax minus 9. Okay, so first off, let's find dy over dx. So we move, for this first value, we move the 2 over, so that's 4x, and remember we take 1 away. For the second one, if you remember, if we have just x to the power of 1, that becomes x to the power of 0, so we just get rid of the x. And then our last rule is that our constants disappear. This is dy over dx. Now remember though, at the stationary point, which is what we're trying to find, dy over dx equals 0. So we can substitute that in, like so. And then now we just have to do basic algebraic manipulation, like so. So we subtract 8 from both sides, divide by 4 from both sides, and then we get x equals minus 2. Like so. But remember, it didn't ask for the x value, it asked for the coordinates. So we also need to find the y value. So how do we do that? So we can say step 1 is finding dy over dx. Step 2 is setting, in fact, let me do this in a different color. So step 1 is find dy over dx. Step 2 is to set dy over dx equals 0 and find x. And then step 3 is to put back into original equation to get y. So we have our x value here, and we know that this is true from the question. So we can just put minus 2 into here, and y equals minus 17. You can check that for yourself, but yeah, that will equal minus 17. So now that we have that, we can write it as a coordinate. So if I just bring this over here, we have minus 2 on the x and minus 17 on the y, like so. Okay, now the last thing you need to know is how to differentiate, how to distinguish between a maximum and a minimum. And there are methods to do this, but the ones that they want you to know is it's not really a method. You just need to know 4 examples. So these are the 4 graphs you need to be familiar with. Now it doesn't really matter what in fact, I'll draw these a bit small. It doesn't matter what you how, like, where they are on the graph. So that's, there we go. Right. So these are the 4 graphs they want you to know about. Now, how do we get these 4 graphs? Well, this these are the graphs of quadratics. So basically, they're in the form ax squared plus bx plus c, where a, b, and c are just numbers, and these are cubics, where you have ax cubed plus bx squared plus cx plus d. So you can see that this goes 2, 2, 1, 0 technically, because x is 0 is equal to 1. And this goes 3, 2, 1, 0. And basically, yeah, these are the form of quadratics and cubics. How can you tell which is which? Well, if you see a power of 3, it's a cubic. If you don't, if you only see up to powers of 2, it's a quadratic. And then, how do you figure out which one this is? Well, if a is greater than 0, it looks like that. If a is less than 0, it looks like that. And in this case, if a is greater than 0, if a is less than 0. So that's what you can do. So for example, something like x squared plus 5x plus 2 will be positive, so you know it will have a minimum point, not a maximum. But something like minus 5x squared plus 17x minus 2, for example, it's a negative. A is negative, so it'll have a maximum. Now for cubics, for example, x cubed plus x squared plus x plus 1, for example, will have a minimum point. It won't necessarily be negative, but you'll know the maximum point, will be before the minimum point. And if you have something like 2x cubed plus minus 2x cubed plus x, 2x minus 5. Now you can see that we don't have an x squared term here, because I never said that b can't be 0, and it can. So we'd have 0x squared, but we still know it's a cubic because we have the power of 3. But this is negative, so we know it would be the second bit. So it would be the minimum point first, then the maximum point. Yeah, so just to recap, we have maximum points and minimum points. Those are called stationary points. At stationary points, dy over dx is equal to 0. There's a three-step method into finding the coordinates of a turning point or a stationary point. And this is how you can distinguish whether your point is a maximum or a minimum. Alright?